how did scientists in the beginning test the validity of the Big Bang Theory, if you could summarize?
Well, that's interesting. The phrase Big Bang Theory was actually coined by an astronomer named Fred Hoyle, who favored a different theory. So, saying the Big Bang Theory, we're talking about a label that was applied in the year 1948 to ideas that people had been kind of putting together over the course of a few decades. So the idea that the universe was expanding, that would have been really shocking to anyone prior to the 1920s. So let's start with Albert Einstein, shall we? Many things about modern science start with Albert Einstein. He had this crazy idea called general relativity that said that space and time, which, ordinary scientists like Isaac Newton thought were quite different, were part of a four-dimensional space-time. And that space-time was it could be bent, curved, warped, distorted, use your favorite adjective. And so in the early 1920s, Russian physicists called Alexander Friedmann said, oh, this is an interesting new theory. Why don't I apply it to the entire universe? I know, really weird, kind of ambitious. But he said, oh, if I try to apply Einstein's equations to the entire universe, first of all, I'm going to have to simplify the universe. I'm going to have to assume it's uniform density as opposed to our own real lumpy universe. But he said, I can't make a static universe. I write down the equations in their simplest form, simplify everything, and either the universe has to expand or contract. Now, Albert Einstein didn't like this conclusion. One of the reasons he thought up the idea of a cosmological constant, a constant term that he could add to his equations, was to keep the universe static, to keep it from collapsing on itself or expanding forever. So, yeah, there was this uneasy period, in the 1920s when Einstein's theory said, yeah, either it's expanding or it's contracting, or you have to put in this special term to keep it static. Now, this was theory. This was one of the periods in cosmology when there were very few observations. However, in the background, all during this time in the 1920s, people were measuring the spectra of galaxies. And they found that the light from the galaxies was, shifted in wavelength. Now, the first few galaxies they looked at, the Andromeda galaxy and so forth, were very close to us, within a gravitationally bound cluster of galaxies called the local group. Okay, and in a bound cluster of galaxies, every galaxy is moving around on its own individual orbits, and some of the galaxies are red-shifted, some are blue-shifted. Okay, that made sense, according to Newton. But as people went out and looked at more and more and more distant galaxies, further and further away, suddenly they realized, oh, wait, all these more distant galaxies, they're all red-shifted, meaning they're all moving away from us. That's the redshift you expect from a Doppler shift. And that's kind of odd, statistically implausible, that everything would be moving away from us unless the universe was expanding. So it was in 1929, end of the decade, that Edwin Hubble had enough data. He had estimated distances to galaxies. Other people had measured the Doppler shifts, and he said, oh, all these redshifted galaxies, the further away they are, the bigger their redshift. So, interpretation, galaxies are moving away from us, and the speed with which they're moving is proportional to their distance. So, consistent with a uniformly expanding universe. The usual analogy is, if you blow up a balloon, the points on the balloon surface move further away from the other points, and the speed with which they're moving apart is proportional to the distance between them. So that was kind of it for a while. Galaxies are moving away from each other in a way that's consistent on large scales with uniform expansion. How do you interpret this? Well, most people trace the beginning of what was later called the Big Bang Theory to the cosmologist Georges Lemaitre, who said, well, if things are moving apart from each other and you kind of run the film backwards, that means in the past galaxies were closer to each other than they are now. And if you run things backward further still, basically, everything was crammed together at a very high density. So Lemaitre, who was originally from Belgium, said this initial state was l'atome primitif. He was a French-speaking Belgian, or as it was translated into English as the primeval atom. He was thinking of an initial state that was as dense as an atomic nucleus. This was kind of the densest thing that people had encountered in the 1930s. And then, for reasons not entirely known, this atom underwent this cosmic fission, broke apart to form smaller atoms, which then distributed throughout space and formed stars and galaxies and planets and people. So what we call the Big Bang Theory today was one possible interpretation of the fact that galaxies were moving away from each other. And people realized that, if things were really, really very dense in the early universe, probably would have been very hot too, and hot, dense things are opaque. So the idea of looking for the cosmic microwave background was there. The fact that it was discovered by Penzias and Wilson accidentally, serendipitously, that's the more dignified way of saying it, was, but it was kind of accidental. There are people, particularly at Princeton University, who are trying to put together an experiment to look for the cosmic microwave background, and they're kind of scooped. So the idea of what we now call the Big Bang was there, and once observations said, this is the best interpretation of everything we can see, both at visible wavelengths and microwaves. That's what made the Big Bang Theory really the accepted theory of cosmology in the 1960s.